Hello and welcome everyone to this week's podcast. We have a very special guest here along with me, Dr. Miquel Alonso, who has been collaborating with me and with Wright Research for a very long time. And we've done a lot of interesting research together. A short introduction about Dr. Miquel. He's a leading expert in AI in finance, in quant investing, and big data in asset management. He has more than 20 years of experience having worked in leadership roles like the executive director at UBS and chief investment officer at Ant Bank. He is right now the co-founder and chief science officer at AIFI, which is AI in Finance Institute, and he leads research in AI, machine learning, quant finance. He is also adjunct professor at various places like Columbia University and ESAID, where he teaches courses on asset allocation, fintech, and machine learning. Dr. Miquel has done his MBA in business administration and economics and also his PhD in quantitative finance from UNED Madrid. His research is very interesting. I think a lot of people follow him on social media, also on LinkedIn. He has a very good following and he posts about very interesting topics in finance, from the mathematics of finance to portfolio optimization, alternative data, and now large language models. So we'll be talking about all of this in the session.
So thank you very much, Sonam, for inviting me. It's an honor and a pleasure to be here. We've been working for a number of years, right? And I also very proud of what you've done and what you're accomplishing and what the future will bring to very talented people like you.
No, it's my pleasure, and you're a motivating force throughout this journey.
Thank you. Yes, you said this is I think a unique moment for probably humanity, not only finance. So obviously for finance it's a unique moment because AI technologies will change the way we work, the way we interact, the way we think, the way we decide things, and also for humanity, for society. These new technologies are starting to change the way we do almost everything, right? So it's very important to be on the top of how to responsibly use these technologies.
Right, and what I really appreciate is that you are always looking at the sort of the forefront of all the research, right? So right now at LLM, but you've done research on reinforcement learning before and alternative data, and you sort of cover everything that is happening in this space, right?
Finance is kind of a science or a task in which it can be extrapolated to many human activities. So it's uncertain. We don't know what's going to happen in the future, or we don't know with precision. Like for example, sports or businesses, right? It requires planning. It requires planning. It requires an understanding of the past to see if the trends of the past are useful in a context or not. It requires digesting a lot of information. So and it requires understanding what humans or how and when and why humans do what they do, right? So I think these are things that, and these things, the technologies we use have changed dramatically. Obviously, I'm a little bit. I've been in the industry for many years, right? And I always explain the same anecdote. I started when Excel wasn't even right.
Wow.
It was called Lotus 1, 2, 3, or even to do a full a regression on 4 variables was taking 3 hours in a mainframe computer of the university, right?
Wow.
So it was really the kind of not dark ages, but it was really unthinkable, right? We weren't sending emails because emails weren't invented, right? And so on. Imagine trying to witness all this, but even I think that what we're living in this moment it has no precedent.
No, but it's really inspiring that you sort of from that to now you have been, right now you are a leading expert in this field, which is so relatively new, right? So it's amazing.
Yeah, this field requires I think everybody will need in the future, right? Kind of at least the ones who want to build these systems, these models, right? A bit of what an engineer or a STEM person has. Like you need a bit of math background to understand what you're trying to accomplish. Can be formalized and so on, can be solved. It requires computer science, obviously, and it requires domain expertise, right? Without one of the 3 pillars, you're probably not going to do a fantastic job. You need the 3 of them. Also, quantitative finance is obvious that you need the 3.
Right, and it requires a lot lot of, I think, statistics and that sort of a knowledge as well, right? I see that you sort of publish a lot on the mathematics of finance, which is really fascinating, right?
Yeah, I wasn't. I didn't start my career studying finance. Excuse me, studying mathematics. But I ended up teaching at Courant, which is one of the I would say best faculties in the world for mathematics, right? So as I said, it's essential to understand the mathematics. Some people get a little bit intimidated, saying, "Oh, I'm not good at maths. This is not for me." And I think this is wrong. Many people, I think the majority of people can do a good job. It's just a question of kind of sometimes courage of saying, I need to keep trying, right? This is not something I understand the first time. It
Right.
requires a few iterations, right? If you give up too quickly, you never accomplish the learning, so to speak.
And I think the intuition that people have also plays a very strong role, right? So many people might have some, they might not like maths that much, but they might have that intuition about how a particular strategy or model should work, right?
Yeah, that's exactly correct, right? You need to understand if you use something on time series. For example, if you're using LSTMs or something like that, if these things are able to understand the typical things they're going to be working with, right? You need to have some sort of this understanding of,
Right.
yes, it seems that the model will be able to understand processes like the ones we're going to work with. Some people just go straight to computing and maybe doesn't understand mathematical implications, right? And today you have lots of tools to be a better mathematician, right?
Right.
Certainly LLMs give you the opportunity to be a better mathematician, a better
Right.
computer scientist, a better finance person.
Right, right. And you teach a course on LLM, which we'll cover in the later part, right? Which is extremely interesting. I think that is something I want to talk a lot about. But to start off with, I'll maybe ask a little bit about your background. Like, how did you get excited about this field? I know that you're extremely interested for a very long time. But what sparked your interest in this?
Yeah, I was born with a, let's say, intellectual curiousness, that has driven all my life, so to speak, in the sense that when I was 14, I was at home reading, right? Well, I was also having social activities, obviously, but I was very interested in reading and acquiring experiences from reading. Then, after a few years, science kind of, I had the calling with science, like saying, okay, I need to read, and I have a library full of mathematics books, right, and science and so on. Right. And I got my PhD in mathematics when I was 40, right? So, which is obviously not an age in which people, is. And I took for example, I was in the new kind of science from Stephen Wolfram, which is a summer school for very bright kids,
Right.
right? And I was there at 38. Right, in 2008, I was with Stephen Wolfram in
Fascinating.
Vermont, in the north of the U.S., right, with very bright kids, and it was a wonderful experience, right, in which this same intellectual curiosity, and I was very inspired by Stephen, because Stephen is a person who's very bright and who's not he's very brave, so to speak, in the sense that I think this is a place in which we can research and so on, and let's do it regardless of the results, or regardless if the other people, right, agrees with the direction. Sometimes you have to be innovation. It's obviously something in which you need to be brave, right?
Right. Right. And
We've passed the phase of innovation. We've passed the phase because now these things are really useful, right? One of the things that people get wrong about innovation is many ideas will not be useful.
right.
Many ideas will just be good ideas that never materialize in useful things. But now we're seeing this technology like materializing in useful, concrete applications.
No, definitely. It's a game changer. So I remember I was talking to my team for some implementation we are doing for a strategy, and they had many ideas, and they were saying implementation will be difficult. I was like, implementation is the easiest thing right now, because you have these models now which are doing most of the work
I
for you.
think one of the things that we've witnessed in the past 2 years is that we've accelerated like 4 or 5 times the analysis and development of strategies, in the sense that from an idea to the coding to the mathematical formalization to the back testing and so on, it's just shorten up like in a factor of 5 or 10, even 10 right now. So you can test in a couple of days an idea, right? Or in a week fully everything. And in the past it was taking you a month, maybe 2 months. I was in a conference in New York, right? And also some big asset managers like Two Sigma were saying that the feature engineering team multiplied by 4 the number of features they were investigating, right?
Wow.
Because you can also use obviously the machine to figure out new features that you want to explore, but also the fact that language has proven to be something extremely, as we all know, right? So we speak and talk every almost all day long, and language has proven to be one very useful place to
Right.
to 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 put algorithms at work, and not only numbers and matrices and so on.
Right, right. It's fascinating. And we'll talk a lot about the LLM. Like I told you that I'm extremely interested in even doing that course with you because, we've done research on the other aspects, but LLM is something extremely interesting. I know that you recently published.
Elements at this point, Ayla, are like you have a very bright individual, right? Probably PhD level in many topics, right? But getting the best out of what the potential of such a person that has such knowledge and so on, right?
Mhm.
It requires a lot of work, right?
Helpful, like even like some of the code, like say we have for the strategies, now I can go to the LLM and get it validated, right? Like it can find or it can optimize that code and it can do all of that, right? So it's amazing type of
Yeah,
work.
we're getting to the point that the
Mm.
coding of Claude 3.5, the coding of O3, the coding of DeepSeek is
Right,
very good, right? So it can write 300 lines of code of something very complicated,
right.
right? The first shot is very likely not going to be perfect. So the first shot is going to be, or it doesn't work, right? Or it doesn't even execute. But with a few iterations, you're going to get there, right? Much faster than getting a team,
Yeah.
developing such a thing.
So definitely, it's a game changer. So I remember, Dr. Michael, when we had met, I think many years ago, you were writing a book on deep learning, and then we collaborated on reinforcement learning. And since then, you've written another book on, I think, portfolio optimization methods. I think you've written something on factor-based portfolio optimization and stuff like that
Yeah.
also, right?
Yeah, this is also, again, something that I started kind of late. So compared to other, we have now one book on artificial intelligence in finance with risk books. Right? The first volume was out last year, right? The December, and the second volume will be out in March.
Right.
The second volume is going to be through the force on reinforcement learning. So I really like obviously I like the first volume. The second is also amazing. We also wrote a book on quantitative portfolio optimization that was launched just a few weeks ago,
Yes.
and we're finishing one book on LLMs.
Oh wow, I'd be
Yeah,
fascinated.
we're finishing one book on large language models. Right.
So because you do, look at this whole set of research, what would you think that, how is the financial space going to transform in the next 5 to 10 years with the use of all these new methods which are coming in?
Yeah, I think that all information digestion will be automated, so to speak.
Right.
We're not going to read. Obviously, we're going to read. I'm not
Mm.
saying skilled humans will not read, right?
Mm.
But certainly, you're gonna trust the machine to read a 10K or a
Yeah.
10Q in a matter of seconds, and
Right.
saying, "Have you seen something, bizarre, or have you seen something very positive, very negative, and so on, or what kind of issues might arise with these and so on?" Much faster, right? Obviously, numbers. Right. So the structured data, unstructured data, right? So it'll all be,
Right.
processed by the machines, right?
Yeah.
Now, obviously, that requires a lot of work, right? These days, let's say things weren't computationally ready for machines, right? So PDFs are built for humans, in such a way they see a nice document with graphs and figures and
Mm.
tables that looks nice and so on. Sometimes this is not the best format for machines to understand what's going on, right? So they still need a little bit of work, right, on being able to read these, again, human made kind of information supports, right, to machines. But I think in a matter of months all information will be digested by machines first,
Wow, that's
and then
fascinating.
And then it's like, I think it's going to be like doctors, right? So you probably have the first diagnose from the machine saying, I think this person might have this or that, or this person is, I think it's in perfect health, right?
Mm.
But you will have the decision, right? I am taking more tests with this person to just be sure that am I sending this to another doctor to see if she or he thinks the same way I do, especially if there's surgery or other things needed, and so on. So I don't think that LMMs will or AI will fully replace a credit committee, but certainly it's going to do the 80% of the heavy lifting.
Right, right, right. No, I think that's a great use case. So I think they call it vertical AI, right? Which is finding use cases of AI in different domains, right?
Yeah,
So
many
like,
domains are kind of scientifically trying to do the same thing, which is looking at a thing and trying to predict or classify or whatever, right? And you need to build a data set and build algorithms to do that and so on. So now all these things, we know much more, right? How to do these things. Still not perfect, but one of the main breakthroughs, I think, of the humanity has been, Mikolov and collaborators with Word2Vec and then the transformers that has given us the tools to some sort of crack the English language or the Indian language or the Spanish language. That was unthinkable, right?
yeah,
And
fascinating.
this is not the end of it, because we what we have discovered lately is that these models are obviously very expensive to train,
Mhm.
right? And very competition intensive. And DeepSeek and others showed us that
They can be done.
enormous gains of efficiency
Right,
just to be grabbed out there, and we'll do very complicated tasks with very little training with much smaller models.
right. That's fascinating.
Yeah.
I remember also, Dr. Michael, when we had talked a few months ago, you sort of mentioned that you were talking about how LLMs are amazing, but maybe specifically for financial application, for example, a portfolio optimization and stuff like that, it might not be suitable, right? So, what are the challenges of such models in financial
Yeah, so
markets?
let me say a word about obviously the advantages. So in finance, there's also the obvious. So finance was a numbers thing, right? Is a numbers thing, right? To some extent. So the
Mhm.
fact that companies, put together financial statements and balance sheets and we look at the returns and the price and all that stuff. These are numbers, right? And we have a long tradition of trying to model this, and we know how hard it is, right? We know how hard it is because we're modeling things that kind of have high entropy, in the sense that there's a relatively high uncertainty over Apple revenues in 2027, right?
Mhm.
So not even Tim Cook knows exactly, right, the revenues of Apple, right, and even less the returns of Apple in
Right.
2027 or 2028. So this is it's like a little bit like sports, right?
Yeah,
Like we have a football game and there's uncertainty of this is not going to change.
it can't
Okay.
change. It is like game theory, like you said.
This continue to be hard because humans have decided that, not decided, but are playing games that are kind of hard, right? Otherwise, it doesn't make sense to play them, right? If you play a game in which you already have an equation to solve it, so what's the point, right? So it has to be an interesting game, right? Certainly, finance is an interesting game because there's a lot of uncertainty over these things. Okay, now how can I navigate this certainty?
You
Is like by trying to understand the situation of the company and so on, by reading, by looking at ratios and so on. And obviously, LMMs can do that, right?
right.
Now, and help us some sort of analyze and find issues and so on this. So that's one, right? Then we LMMs can also be used to generate scenarios, right? Some people says in finance, some people says we don't like artificial scenarios, but we're doing that all the time, in the sense that now we're all thinking about, for example, how tariffs are going to impact U.S. companies. Everybody in the planet is trying to figure out these still tariffs, right? How are they going to impact,
Right.
U.S. companies in the S&P and Nasdaq and Russell and so on. So I remember vividly, right, once that we have Robert Litterman, and he said something that everybody needs to have. Many problems we're trying to solve are looking forward problems. right?
Mm.
Things that have never even happened, scenarios that we have never explored, like
Right.
this one, in which we have a new technology, we have new kind of new some sort of geopolitical,
Right.
completely new geopolitical background, so to speak, and we need to take decision and forecast and do predictions in this never witnessed, right? Okay. So generating scenarios is very important, right? Then, obviously, LMMs can help us do mathematics, can help us do coding. So even if you're not trying to cook, in order to do some of the essential tasks that quants and also fundamental managers, right, that look at companies with a more, let's say, fundamental or qualitative, are also, using them heavily, in the sense that read that, give me your opinion, and so on. Okay, so maths and coding efficiency is something, that generation of ideas there is also something. And on the quant side, and that's why I said before that we need a lot of work, right? I said, reading documents is tough, right? Reading tables is tough, and so on. And it's not easy to get the LMMs do all these tasks with absolute precision.
Right. That makes sense. But I think you are a big fan of reinforcement learning, right? Like that is the solution that you really like.
Yeah. I wrote a paper this week, and
Oh,
you were also, an early proponent of
yes.
reinforcement learning, right? And LMMs are reinforcement learning agents, right? So LMMs are some sort of a sequence. LMMs try to predict the next token, right? But after digesting,
Mm.
your prompt, like say you've asked what is the capital of the United States. Obviously,
Mm.
this is a very simple one, right? But many other tasks require much more, right? So if you think about it, it's like a reinforcement learning agent, right?
Right.
That kind of absorbs the state. The state is the prompt, for example, right? And try to figure out what's net actions that I need to take, right?
Right.
And I have a discrete set of actions. I can go, well, if it's a very simple game, right? Like AlphaGo, no, but it's not simple, but let's say one of these Atari games, right?
Mm-hmm.
You have only three potential actions, and so on, but you have 50,000 words, right?
Mm.
So in English, so to speak, they can follow, and so on. So this can be seen as a reinforcement learning
Right.
game. And you could think about an AlphaGo or of an Alpha Star, which was developed in 2016. Kind of, they were doing the same thing, but instead of doing it with tokens, it was done with pieces in the board and so on. And they started to show that the machinery actually learns how to play, right? So
Uh-huh.
the LMM also learns how to talk, right, and make good sense of stuff, right? We lately have discovered something that was also in this early, some sort of RL breakthroughs,
Mm.
that it's not that easy to choose actions, right? So the test time compute that it's in the press right now, saying test time compute, which is also an amazing development, right?
Mm-hmm.
It's like we need to explore the space of actions. We need to explore the space of tokens, right?
Right.
And this has a lot of value. I rarely can do things one shot. I ask something and the machine responds, this is not good enough. Right?
Mm.
But after a few iterations, you got there, right? So this idea that I need to iterate, evaluate, it's like similar to a value function and all this machinery. So I think RL is the framework that some sort of rules everything.
Right. Right. And I think in a field like investing or trading or execution, right? That is also where reinforcement learning is the thing that.
It's other enforcement learning task. It's a multi-agent one. It's a tough one, right?
Mm.
But it's certainly a multi-agent reinforcement learning task, right? So, and some of the breakthroughs that we've seen in elements are right. When we started using RL, for example, to do RLHF, DPO, and GRPO, right? And Chinese teams have shown to be some sort of very nimble at using RL there. And with RL, you might not need trillions of weights, right? Because you have maybe you have a more specialized model that learns something. You don't need to learn the Roman Empire
Right.
to try to solve a numerical problem. This is something that we will learn obviously how to not use these tokens, right? Because obviously I don't need to know who's the emperor
Right.
of Rome in a specific year. I only need now the maths to do something specific.
Right. I think like the DeepSeek model was a game changer, right? Sort of innovation that they brought in.
Yeah, I think
Uh,
the latest developments that we've seen is that we can build smaller models, right? Better trained with better data sets that will be better than obviously the first O1, the
mm,
GPT 3.5. I mean, O3 is much better. DeepSeek or Claude 3.5, even Grok 3
right.
are much better. And it's not only about, again, it's about this test time, right?
Yeah.
It's letting the machine iterate, right? Letting the machine look at solutions, evaluate them, do it a bit more, and then say, I think this is the solution, or I think these are two good solutions. I'm going to show you one, right? And so on. Depending on the problem, there's one solution. Sometimes there are a few. Sometimes there's not really a solution, but there's a set of reasonable solutions, so to speak, right? For
Right.
example, when we do predictions in high entropy environments, there's no such thing as we cannot say this is the solution because it's a high entropy game.
Right.
We don't know it's going to be the score of the man-human city. And we will never be able, right? And if we will, then all the mystery is gone. We don't need to play football.
Right.
And
Yeah.
yeah.
That cannot happen, right? I hope.
No, I think it's activities that will keep, right? So one of the things that people doesn't get about AI is that it's gonna do, right? I think everything that humans do, AIs will do it, are doing it with same quality, much faster, right? When I
Right.
say much faster, it's like not a nanosecond faster, because again, the machine has shown us that it needs test time. It needs time to find some options that seem to be good solutions, evaluate them, choose them, and you need a few seconds to do that, or
Right.
sometimes minutes, right? Sometimes
Yeah.
it's really, if you're asking about go and read Apple 10K, right, or 10Q, and try to find inconsistencies, for example, right? Obviously, the
Right.
machine is going to need time to do all that.
So we talked about quite a few areas of research, and next I want to cover the LLM course with you. But anything else which is interesting that you in terms of research, I remember we did something on overfitting of financial models, right? How overfitting might be a solution, right? If you remember that, instead of bias variance trade-off, we thought that it has a W curve, right? That with
Yeah,
overfitting,
yeah, we wrote a paper, you and I, about uh,
yeah,
and certainly, there's that's why you need skilled users, right? Oftentimes, when the LMM is not aware, I think LMMs are starting to be more and more aware of. I'm giving you the results of the man-human city, but be aware that
hmm,
these things cannot be predicted with precision. So
right,
don't bet all your ranch, all your farm on whatever I'm saying
yeah,
about the result of man-human city or the
right,
revenues of Apple next
right,
year. Right?
right.
It's just a prediction, and we're not. And this is a high entropy thing, right?
Right,
We cannot build, but we're thinking of maybe LMM help me to be 1% better, right?
right, right.
And this is 1% better, which we're all looking forward, right? It's
Yeah,
like
that's
a
the
marginal increase in a tough problem might be very valuable for the humans that achieve that, right?
right,
It's like, think also about when you play basketball in the NBA, the 3-point shooters have a precision of the best ones of 30, 37, 38, and so on, right? You cannot imagine a human shooting at 100%, right? It's just not. It's just a problem that is too hard for humans. You're being defended. You're nervous. You're there. You're now in other position, and we're not kind of mechanical machines, right? And so we're tired, and all these kind of guys. There's factors that some sort of make impossible to have an absolute precision, right? For example, in the sports tasks, right?
mm,
But getting 1% more, increasing your shooting ability 1%, it's a lot of points after 60 games, right? So
right,
this is okay. Assuming that other tasks that can be solved are already not a problem, right?
mm,
Because we've already, all machines will help us. This is another thing. Machines will will allow us to introduce new concepts. I'm sure that in a few months somebody will say machine has developed a new taxonomy for stocks in which these are modes, but with this and that.
Right. But like these predictive models, I was reading somewhere that, financial markets are second order chaotic. What that means is that if I knew that, if everybody could predict that Apple stock price is going to go from 100 to 150, we'll all buy it today. And the price will go to 150 today. It will not go to 150 a month later, right? So your predictions will become wrong if you could predict the future. That's also a
Well,
thing.
obviously, there's feedback effects. Yes, of course. Yeah, that's a good point, right? There would eventually be feedback effects in the fact that if that happens, what the market would do if it says this element has precision, right? So it will get to the price in a matter of seconds because everybody will push in that direction, right? So that's a good point, right? It reinforces the idea of reinforcement learning. So markets are kind of a reinforcement learning game, right? In which agents are observing an agent change their behavior. You also need to model other agents that are competing against you, right? For example, when we have always a lot of questions about how the ecology of the market is going to change, and this is a thing that everybody needs to pay close attention to what extent this is going to concentrate the market, right? If it does concentrate the market, at some point, obviously, this is not good. The market's getting crowded and markets might be more abrupt and so on. So regulators should also have some sort of keep an eye close on these potentially more concentrated markets, right? We've seen that many times, right? I'm not sure that this is exactly what's going to happen because again, right, LLMs cannot be perfect because there's two. Again, you can't shoot threes at 100 except if you use a robot, right? But again, this is not a place in which you can build up a perfect prediction of Apple revenues for 2028. It's just not possible. There are too many. It's a highly dimensional thing. There's uncertainty over all of them, and you cannot navigate past through. But again, your job is to be 1% better than others, right, or 2% or whatever.
Right. And
It's a competitive game. Yeah.
So let's
So you were
let's
asking about the course. So in the
yes.
course, we're basically that starts the 10th of March, right? The next cohort. What we do is we go through, all important steps, right? You've also witnessed the developments of NLP in finance. So at the beginning, right, in 2017 or even as 2018, 2019, people was using algorithms that were more based on frequencies and so on, trying to say, Elon has said more positive words than negative words, and it means that he seems to be positive about, going to Mars and so on, right? And we developed algorithms that were doing that, right, in the computing sentiment, right? The sentiment is a tone or of a text or of a conference call or earnings call and so on, right? Okay. So we start the course with NLP, trying to see what challenges you find when reading text and what are the useful things, right? And still this is very useful, right, knowing about NLP, because for example, yesterday I was looking at some very interesting research about you pick the earnings call, you look at the on topic of topic things, proactive and reactive and so on. So people is looking at a lot of dimensions when it comes to the communications of a company, right? Be it verbal or written, right? So when the CFO of Bank of America gets unscripted questions, this is a very saucy, people finds very saucy section of the interaction, because you kind of can see a little bit more raw, what's the mood, so to speak, of the CFO about next quarter, right? Is she positive, is he or negatives and so on. So we start a bit discussing all these challenges that are still very useful, and then we start looking at user cases, right? And then we navigate through the essential things, which are: do I need to build my LLM, which would be obviously something that if you have a lot of money, right? So building an element from scratch. Our answer until now has been, it's very unlikely that you want to build an LLM or from scratch and so on, right? Because of this and that, right? But we're also seeing that the more tools we have, the more we understand transformers and the data sets. We're trying to see that sometimes you can build a smaller model that does something better than general purpose LLMs, right?
Right.
So you have to be some sort of so building one from scratch is something that, but obviously, the big questions are, do I need to fine tune? Do I need to do LoRa? So these are things that we discuss. Fine tune is about, I need to the LMM do a specific task, and I'm changing the weights. And obviously there are billions of weights, so it can be also very costly. Maybe not
Right.
that costly as training a model, but we develop LoRa, right? Or some bright people develop LoRa and so on and so forth, right?
So, talk about, let's say, the mechanics of an LLM, what goes inside it for somebody, who wants to learn what foundational model is and what is inside the LLM.
Yeah, we're learning more and more what's happening inside, right? For example, last week I wrote a paper about the guys from MIT, Leckmark, and others wrote a paper about numbers that are helical representations in LLMs. That's amazing, right? That's amazing. So obviously, one way to try to, you learn high-dimensional vector representations of words, tokens, and as numbers are tokens, machine also builds a high-dimensional representation, right?
Right. What when meant was, how to, let's say, build a LLM, or how an LLM is built. Do you, in this course, is that aspect also covered, or is it more
Yeah,
of?
yeah. We're learning more and more, right, about how they work. Even Anthropic was saying, I don't know, in a podcast, I don't know, a month ago, we just don't know a lot what's going on, right? And that's true, right? The LLM is trained and it acts like very human-like, right?
Right.
Obviously, this needs to be tamed because you need the human to be well behaved and not say bad word, dirty words, and not build bombs and all that kind of stuff, right? But there are also consequences when you try to modify that behavior, right? There are also lots of things that we're learning now, again, about the nature of how they do mathematics, right? And we'll see a lot of improvements there, right?
Right.
I think we'll see a lot of efficiency on building smaller models that are better to do specific tasks, right? Scientists need to learn that LMMs will not be the solution for everything, right? Sometimes you need to build your own model, but we
Right.
have lots of tools right now to build a model, use transformers and so on. But you need, again, bright scientists that are able to connect the dots, saying, we have this data set, we're trying to answer this question. How can we best do that?
Right. For example, see, if you ask an LLM which stock is going to work, it's going to give you disclaimers, right? Like in a general sense. But even if you, like, for example, if I ask it about a strategy to build, right? What I've seen is it also gives you disclaimers, right? Even then, until unless you ask it very, very specific, it's still giving you very vague. And I
Yeah,
think,
yeah, that's a good point, right? So I cannot stress enough, right? So we've all gone through phases on which we've said, prompting is very important. Then you say, oh, it's not that important. I can type loosely and still understands me, right? And so on. But let me deep dive on the question you asked. What's the best stock for next quarter, right? And you can ask questions like that to an LMM, right? What can likely happen, right, is that the LMM goes and says, I'm going to go to internet. I
yeah,
found an article from whatever person has written saying this will be the best performing stocks, right? And obviously, you're not satisfied with that kind of answer. You're saying, okay, the machine has provided an answer. Again, this is what I said before, that you shouldn't normally trust one-shot answers because they're not well cooked, right? So it will oftentimes not be a good answer. It's going to pick somebody else's opinion about the market, which you're not interested, right?
right.
So every time that you ask difficult questions, right? In reality, what you need to do is a much better prompt. Let's say, I want you first go to look at, I don't know, what happened last quarter with returns, what happened last year with the returns. Was this a good performing? Now look at the valuation ratios. Does it seem expensive, cheap, and so on? Now look at sentiment. Now also look at, I don't know, ESG factors and so on. It's like you're training a new person in your team, right? And your person has no experience in football, right? So you're gonna need to say, I'm expecting from you to do something similar, to be looking at all the factors, to looking at, okay. So prompting is essential in this kind of tasks, in which otherwise the answers of the element can be all over the place, right?
Right.
And it's highly dangerous. Other problems, right, that everybody needs to aware are cut-off problems, right? Or the machine that hasn't read what happened this morning. Imagine this morning there's an announcement of Apple that we've invented this and that, right? Machine hasn't read that, right? Or if it had, right, it's still too raw to some sort of, right, you need more confirmation or not, and so on, right? So cutoff issues are also relevant things, right? Other things that you should be aware that might lead you to some sort of solve a problem differently is the fact that arithmetics, because of the representation of numbers, right, in LLMs are not perfect. It means that maybe you're asking, does other results better than last quarter, and the machine mistakenly thinks that 120.35 is some sort of less than 119, right, for some reason, and so on. So ordinality, precision in arithmetics, it's still not perfect, right? So there's a long list of things that a scientist needs to understand, right? Because you can't afford sometimes this loosely precision on saying, oh, I think the results are worse, right? And they're actually better, right? Things like that might be, right? So they require a lot of work, right? And I still think that you need very skilled humans, right? Behind to some sort of, put together a portfolio, put together a set of stocks with returns. You need the human supervision, unless you've already built a model in which everything the LLM does is something you would approve, right? Is something you think is being correctly done. Numbers have been correctly digested. The operations are precise, and so on. So agents are very important. So that's one thing I wanted to say, is that agents, artificial agents, will be, that's so we also speak and teach about agents.
Okay, awesome. You mentioned NLP. So have you seen that the LLM is beating all the traditional NLP techniques now?
NLP is not, so LLMs, right? That's why it's so important to kind of have NLP notions, right? Deciding if you're on topic or off topic, it's already a tough NLP task, right? Deciding if you and I now we're on topic, that you've stated a question and we're talking about this, and I haven't digressed into, sports, or you see what I mean, right? So there are lots of NLP kind of that require, right, you thinking, how do I best train an algorithm to decide if you and I are on topic or off topic when talking? That you state a question and we're still on topic talking about these things, right? Or am I, as a CFO, constantly changing topics because I don't want to answer your questions? So this would be like politicians, right? That they're asked about one thing and they answer by not answering, basically, going off topic. Or a proactive, reactive, like do you give more information that you were asked, or you're only answering questions succinctly, which would be reactive way to answer, right? So these are things that LLM will kind of understand the concept. The question is, I need to prove myself that the LLM is good at doing that specific task. Okay, so there you need to put your NLP hat and say, how would I solve the problem of on topic of topic? How would I, right? You see what I mean? And this is not an easy NLP task, right? Okay, so many of the things we're going to try to do with the LLMs or are tough questions, right? That we as a scientist need to understand. How would I do that? If I were a machine, so to speak, how would I do that? Do I need a labeled data set to do that? Do I need to build a data set in which I teach the machine what it means to be off topic, right? And then the machine says, oh, I understand. Is when you start talking about football and the interview starts talking about the war in some country and so on, right? You see? So very interesting question you ask, right? But again, right? LMMs one shot will probably be bad at solving that. You're probably going to need to be, you maybe need to prompt them, right? So verify that the answer is aligned with the question, right? Aligned in the sense that it's the same, a similar topic, is the similar science, is a similar entities being mentioned, right? And so on.
Right. So we did discuss that maybe on the sentiment analysis. I think even entity prediction and stuff like that, event detection and all that. We've seen that large language model does better than, let's say, a traditional BERT or some other model like that, right?
Yeah, let me rephrase that. I mean, you need to also think about, will I need to build a BERT like sentiment machine instead of with a label data set, instead of trusting that an LLM prompt,
right,
is kind of understanding things like the first time it sees COVID, right? What the LLM is going to think, right? And things like that. So we cannot take for granted. And I think this is, let's say, I think in the end, we all need to have one thing in mind, right? Is that complicated tasks, probably the LLM will have a zero ability, not a zero, but a 10% ability at the beginning. For example, this question on topic of topic, right? Maybe it has here, because it's a language task, maybe a 20%, right? But you're probably going to need to show examples to the LLM to what you mean about changing topic, being off topic in a financial context. So when the CFO, because you might say, now he's talking about other banks, right? And machine might think, oh, this is another topic. It's changing entities. So this is an off topic. And you might say, no. It's very relevant that the CFO speaks about the peers, right? It's pretty relevant. It's not an off topic thing, right? You see? So pretty much all complicated tasks, the machine will have at the beginning, let's say, a 20% one-shot precision. And you say, well, you can't work with a 20% precision in any task, right? But you will discover that if you teach the LLM how to correctly evaluate, right? You show it examples and so on. Maybe the precision goes to 75 or 80, right? See what I mean? One very interesting experiment was this art contest, right? In the art context, you use LLMs to do some sort of visual tasks in which you have a square of 9 by 9, right? And the machine needs to learn to do transformations, symmetries. And LLMs have never been trained on such a visual task. Nobody has told them, right? And the first iteration they do is very bad, right? But then you start saying, I'm going to build a data set and I'm going to fine tune not the whole LLM, but the transformers. To be able to learn that task, I don't need language abilities, for example. So this is a very nice example. I don't need the language abilities. I don't need to be speaking English. I just need to the transformers to understand how to perform transformations in a 2D kind of square. They've never done that, but I can build a data set which I'm artificially generated. And then they learn, they get to something like 75. And at the beginning, they were kind of zero. They were doing all wrong. This is an example of, it will require some work. The transformers and LLMs are such a universal machine to do some sort of intellectual task that we'll probably get there with a little bit of more work than just prompting, right? Or just, I will never advise to trust, for example, again, this idea of on topic of topic, or you need to even put together a data set. We have 5 earnings calls and we've chosen a few examples. This is off topic. So here the CFO changed topic because she didn't want to answer the question. It was an uncomfortable answer. She decided to talk about, or she directly refused, saying, we don't think these are important topics I'm not going to answer, and things like that.
And I think that's where your RAG model also gets in the topic, right? Like it gives more context to LLMs. So will you talk a little bit about the RAG model also?
We also talk about time series foundational models, which is something that everybody is also seem to be right. There we're not positive. There we think LLMs are not suited to do financial time series.
No, that's too complicated. I don't know why
that's a bit what I was saying, right? The machine, you need a more specialized algorithm that is going to do that. You need a data set that you've put together, that you've created, and then use it. right? We don't think general purpose time series models are useful at all.
I think what you said about scenarios and using that in black letterman and doing all that, that is very fascinating. But time series modeling using that, I don't think that.
That's what I'm saying, that your scientist, every scientist in 2025 needs to be very, very on the top of things, right? LLMs are not solving everything. They seem very smart, but you can be tricked by being apparently smart because
Right.
maybe they've never played paddle and they're terrible.
Right.
Maybe they're very good athlete, right? And they
Right.
kind of, after being trained, they playing well at tennis, but I'm sure that the first shot on playing paddle is terrible, right? Because the machine still doesn't know how are the best strategies and so on. You need to instruct, right?
Right.
And this happens with a lot of problems. So scientists need to be again very clever, right, in saying, will the machine, and you need to test the one-shot abilities, right? Evaluation is a key thing, right? You should be able to evaluate. And here we wrote a paper about this look-ahead bias. Some people from Chicago wrote papers saying LMMs are better than humans, right, in picking stocks. And
Yeah.
after some, you say this is all look-ahead bias, right?
Right.
You can't ask an LMM about 2010 thinking that you're not going to have look-ahead bias, right? You
Right.
cannot.
It is the whole data, right? The whole news, in a sense.
That's exactly correct, right? So that's a lot of things like that that scientists need to consider when doing tasks, right? But again, good ML scientists will say, I can build an LLM kind of framework, I can build a data set with a little bit of work and see what happens, and see if I increase the abilities of such a specialized machine that is kind of a supervised slash RL machine again.
Right.
In
Right.
the end, you're building an RL, SL, supervised learning machine, right?
Right.
But you say, I'm giving the LMM or I'm giving such a model the right context, the right training examples, and so on. That's
And
crucial.
that's where the retrieval augmented generation, right, the RAG framework comes in, where you are supplying specific data sets for the prompt that you have, right?
Yeah, for example, right, you've been working on, imagine, right, we had somebody in the course. In the course we've had people from all the banks, right? SocGen, Bank of America, right? Lots of banks that are trying to solve very different things, like, for example, monetary policy, right? In the and so on. So RAGs, when you have, I don't know, you've written some internal report that you think is crucial for the understanding of a specific topic, and you want to expose to the machine, and there's still challenges on RAG because there's still challenges on reading PDFs, on reading tables. We're getting better, but there also I advise the users to be very practical, right? If you really think that the PDF ingestion is not working, maybe you need to think about, I need to build a data set with the information and the PDF. Maybe I need a special machine that is going to translate this to another data set, and then I'm going to use this data set. It's curated. I know it's correct, right? So people these days is doing that, right? Like, you do RAG, but many times you need a very specialized RAG depending on the PDF, and then you need to curate and you need to build specific algorithms to deal with specific problems. But there's a caveat on this, is which you only need to do it once, because once you do, you have all the historical, then you don't need to redo that, right? So you have a curated data set that has all the correct informations, that it's well retrieved and so on. So you need to get there. You cannot trust that magically LMMs and are gonna. I'm sure in a few months, I don't know, for example, if you use Gemini, it's already starting to be very good, right, at ingesting PDF, very, very large PDFs, right? So RAG is probably not going to be an issue, not going to be even a thing we teach in a year, right? Another thing that is very important that I want to stress here, right, is also the fact that LMMs have also time blurred. Okay, they're not necessarily very good at chronology and so to speak and so on. All your RAG should be timestamped. Some people is not doing that. This is a disaster, right? You know about markets. You know that you need to synchronize the clocks, otherwise it's very easy to do look ahead bias, right? If you don't synchronize the clocks and you say, when things are happening here, that's this time, but it's 6 hours difference and it's this time. If you at the beginning, when you start, you don't do that, and you do a lot of mistakes, crazy mistakes, because you're embedding look ahead biases in your models that
thing, right? And
so all these things are still, and LMM will not be aware that this is a critical issue, because to answer questions, oftentimes humans are also very loose at the time sequence of things, right? You have blurred memory, you're cheating so all the time with the past.
Right.
I already was in love with NVIDIA, right? Like 3 years ago, right? Yeah, but show me your portfolio 3 years ago. Oh, you don't have it. You didn't have NVIDIA, your portfolio. Yeah, well, but something somewhere in my mind, I was thinking that NVIDIA was special, and so on. All these kind of things.
Yeah, no, I think that's a very big deal, right? And any model that has a look ahead bias does not work in the live environment, right? That's a challenge.
That's why we still cannot say, right, that LLMs are better or worse than. I don't see reasons on why LLMs would be bad stock pickers, right? It would say they're better, they have more memory than us, they can read more than us. But also, I have bad news, not bad news, but I think it was 7 years ago, a student at Columbia said, my dream, Columbia University, my dream is to read everything has ever been written about Apple, right? And then I'll have perfect knowledge. Right? I said, is this giving you an edge to predict? No, probably not, right? Something that happened 20 years ago with Steve Jobs. It's nice to have fun when you're with some finance colleagues in a bar saying, right, remember that interview from, and so on and so forth. But it's not giving you an edge of what's going to happen with revenues of Apple in 2 years.
Right.
So this is also something that everybody needs to understand. Everybody comes to the course and says, even financial professionals, it's unbelievable that say, if you solve RAG, you're done. No, you're not.
100%.
You're not. You're not. You haven't solved the problem, which is, can I predict better than my neighbor, right? Something, right? And knowing anecdotes about the past isn't giving you probably any predictive additional power and so on. But maybe one thing that it's interesting is this multimodality, the fact that we can, but also there you need to be very, very careful about multimodality, because multimodality also requires you setting up the clocks correctly. So when the CFO said that was New York Times, that markets did that, I need to synchronize all that perfectly, otherwise I'm cheating and creating problems. So you need to do a very thorough work with your data sets in order to say things about.
Right. And even talking about financial prediction or, the companies, to go a little bit off topic here, I was part of this lecture course by some professor at Stanford University in their program, right? And what they did a research, more behavioral research, where they proved that in many of the decision making that these companies do, emotions are the biggest part, more than the rational decision making, right? So how will a machine sort of predict that aspect, right?
The machine inherits biases. So if the machine is asked to be a CFO, right, you're probably writing a similar style, right? When you see a balance sheet, you're writing a similar style, right? Like it's forbidden to be pessimist. It's forbidden. You should always find, good answer for tough questions, right? It's like a coach, right? You've lost 3 games, right? You need to be moderately optimistic, right? Which is probably the right way to you see. So the word optimistic is something the machine will learn, right? And there's always the question of inheriting these biases, good or bad, right? But certainly a CFO, if you ask the machine to write and it doesn't have similar biases, it wouldn't look natural, right? So some people is asking the LLMs and say, now humanize this. It's very funny, right? Some people is saying, now humanize that for me. It's like, you provided a very formal answer. I want you to be a little bit more human, right? And you kind of inherit these biases that if you're selling something, you're kind of need to show, obviously a positive attitude versus the topic. You need to be well presented, and all this kind of stuff, right?
Right, right.
That
That makes sense. So we talk a lot about the course. I want to quickly talk about the work that you do at AIFI also. I've been part of a couple of boot camps. So you guys are still, you're doing that offline right now, right? I think during COVID it was all
yeah,
online.
we offer a more general AI course
Mhm.
on the 17th
Oh, wow.
March starts. And I think this is where you should start, even before thinking about LMMs, right? Just because I think it's better for scientists to first learn supervised learning, first of
Right,
all, right?
right.
It's like you're asked to do predictions
Mm,
pretty much all the time, and you need
right.
to first learn the algorithms that seem to work. How can I code them and so on when I'm doing I don't know return predictions
Mm,
and all that kind of stuff. Learn the algorithms and learn the maths and so on, right? And learn reinforcement learning, learn NLP, right? And
right.
after that, you say, okay, now you have this tool, right? That will allow you to do some of this faster, to replace some of these, right? But again, I think that this arc thing was kind of a confirmation of what we were thinking, right? If you do
Mm,
time series, you need to do supervised learning. You cannot use a general purpose
right.
algorithm. For many tasks, we will discover that a well-trained, smaller algorithm will do a much better job
Yeah.
because again the LMM has been trained on many things that are not relevant to the very important question you're asking. You're only interested in one question, but you're interested in having your algorithms fine-tuned to that question,
Right.
not
Yes.
on the fact that they've been trained on safety and so on and so forth. That's very important for a general purpose, right? But the future will be kind of scientists being nimble on that, saying the first place to go is an LMM. LMM will probably not be good at very specialized tasks. In
Right.
markets also, because think about it, right? If you ask a question of high frequency, machine has never been exposed.
Right. Right.
You are an expert. Machine has never, right? A machine has read articles on all the books and kind of stuff. So it has some sort of a general understanding of these, right? Of
Right.
other books and so on. So it doesn't start at zero. You need to infuse this expertise, right,
Right.
to a model, probably to a smaller model, right? Because here you probably don't need language skills, but you need numerical skills, but
Right.
very
Yeah.
fast. So you don't need to wait. You can't wait inference time of a few seconds because the LLM is figuring out something, right?
Right.
Because it's activating too many layers, it's activating too many weights, and so on. You see, so I think that at the same time you can build this with LLM. So you can ask the machine, build me a machine to do that, right? Build me the code to just build me some examples.
But you need a lot of expertise. So, for example, when I work with, let's say, interns or people, what you would see is that they've all gone to ChatGPT or they've all gone to an LLM to build their system. But many a time, they will have some very, very glaring look ahead bias that, the machine has not spotted.
Absolutely, or just very trivial answers that are not interesting or useful. Again, the one-shot abilities, you need to think about in complicated tasks, in tasks in which the LMM hasn't seen relevant, the one-shot abilities will be around 10%, 15, 20. It's not enough. It's
Yeah.
by no means enough, right? You need to train the LMM to understand the essential concepts here. Where should it be looking at? And maybe you need to build your own transformer model to look at the problem, because then you control the data set, then you control the weights, and there's no interference on things that builders have, you see. So I think this is why it's so important you need a deep understanding of what you're trying to do. If you're trying to teach the LMM to be a football coach, you need to be a football coach, you see,
Right.
because you're going to need to you're going to spot the problems, right? You're going to try to say, oh, you have to watch this game in which what you were seeing it's not correct because the others did this and that and it didn't work, and so on. You see what I mean? So to some extent you will create a data set
Mm-hmm.
of experiences in an RL lingo, a replay.
Right.
You can maybe say, I've asked the machine to play a million chess games, and now it seems to be better, right? But the LMM abilities to play chess might be already reasonable, right?
Right.
But it
Right.
won't be a master unless it does all the work of fine-tuning their areas of to these specific tasks,
That
right?
makes a lot of sense. Yeah.
Yeah. So I think this is the specialized versus general purpose is that, and general purpose again, right, are good for some general tasks, are unbelievable because they have such a,
Right.
but you want to do typically a precision work. You want to do
Right.
you want to be better than the neighbors. You need to do fantastic work,
Right.
and you need to say, okay, before talking about tariffs, I'm going to put together some examples for the
Right.
machine,
Yeah.
right? Like saying this would be the potential, and maybe the LLM can help you to build this set
Right.
of examples, right? That then you're going to use. Right, to some sort of have the final model, right, and the final prompts, and or a fine-tuned model, right, that kind of does this better than my neighbor, and you can win the art game, right, the art contest.
Definitely. That makes a lot of sense. I think you've sort of demystified the whole concept to a lot of people who might want to know how LLMs and how AI is going to transform investing. So,
Yeah, so that's what I'm saying, that the more we know about what's happening inside, also is very important, because the more we know about, the more we know ways to alleviate problems, the more we know about simplifying models, right? Simplifying models is very important in the sense that, right, again, LLMs are very expensive to produce, inference is expensive, and so on, right? But we're getting there in the sense that we're learning. I mean, nobody was kind of so positive on test time. And test time has proven to be something like the way machine thinks
right.
is like putting on the table alternatives that might be good solutions for a problem and evaluating them. And then if you haven't found a good one, maybe you say, oh, this is a really tough problem. Do you think it has a solution, or do you think I can solve this integral, right, and so on, right? But even in this, when mathematicians wanted to do integration, I think you've attended some of the Francois Charton from
Yes.
Meta. You know, they did a similar thing. So they teach transformers to integrate, but you had to be very clever, right,
Right.
to give them enough examples, enough diversity, right?
Right.
So this is one thing that is problematic too, right? It's the fact that LMMs have been probably exposed to boring knowledge, very repetitive, right?
Right.
So always only multiplications of 1 by 1 or 2 by 2, and you probably say, you know, I need to teach the machine to multiplications of 4 by 4, things like that, right?
Right.
And again, you look at the data set and you see the machine has only seen 10 or 1,000. The machine is going to extrapolate what it's doing with the 2 by 2 digits,
Right.
but that might not be enough, right? That might not be enough to kind of solve that problem, right? And then maybe you're not even happy with that, and you say, no, I'm going to use tools, right? Every time that I say multiply, go and use a calculator. I don't want you to guess or second guess or just build a neural representation of a multiplication, which is a big hassle when we already know the answer.
Right. That makes a lot of sense.
Yeah.
Yeah. So I think specialization is what is going to sort of give you an edge, and obviously LLMs are going to add.
Yeah. Think about this. I think this is a good message, right? One shot abilities. It's like a human that has never been involved in high frequency. Probably even if it's a finance person, the one shot ability to answer questions probably going to be a 2 out of 10, right? So if you take an exam, if you've never been trading, or you have just general understanding of what's an order book and all that kind of stuff, right? You're probably going to be 2 out of 10 answering questions. You're going to say, yeah, you don't know shit about this. No, I've never learned or being exposed to. I don't know the nitty gritty and so on. But if you use it for high frequency, you need to be, an expert, right? So how you build an expert is your job, right? To talk to an expert of high frequency that some sort of shows examples or even teaches the rules, right, and so on in a way that the machine doesn't need to uncover rules and so on and so forth. But and then what's left probably that I haven't mentioned a lot is that this idea of iteration is absolutely very powerful, because then scientific progress, it's about iterating. And then you say, I can iterate a problem in a couple of days, millions of times. I can be exploring much more than a PhD student could 2 years ago with And proteins are an example, right? I can literally iterate these, use brute force, right, to explore all the potential solutions. So the scientific progress will be exponential at the beginning, because again, you have a problem, you iterate solutions, but much faster than
Right.
humans.
Oh, that's
So
perfect.
test time compute is in the end the driver of right, is kind of the driver of or reinforcement learning.
Right.
It's like
But
everything is a reinforcement learning problem, right?
yeah,
And somehow the spicy thing of exploration, right? Because maybe I find better solutions in things that are apparently uninteresting, right? For example, right? And the move 37. Was this an example of creativity? Well, the machine kind of figure out, if I surprise my human, the human thought, right? If I surprise the machine with some bizarre movement, maybe I confuse the machine, and he confused the machine, right?
right,
And game theory tells us that sometimes you have to confuse or your opponent, right? Like
right,
saying playing football, instead of and trying to fake that I'm going right and I'm going left, and all this kind of stuff. When you are playing games that are game theory, non-Nash optimal, multi-agent, all that kind of stuff, right? So also surprising your opponents you might be the winner, even having less skilled agents, less
that's
skilled agents, just because you drive the game into a place in which the machine seems to have zero knowledge or,
right.
or or little understanding of what's going on. So you should drive the machine there. So think about, you also need to be clever about adversarial people trying to mess up with your newly built model.
Right.
And people doing high frequency knows a lot about that it's about surprising your opponent, so to speak,
Right.
surprising the rest of the market with new strategies.
Right. That's makes so much sense.
uh,
Uh, awesome. So we covered quite a bit of it. I know it's very early morning for you, and I
no, no,
have
no problem, no problem.
taken a lot of your time. I think this was an amazing conversation. I sort of learned so much, right? I think
Yeah,
obviously concepts about these things, but the real world examples and the key challenges and how you can actually leverage these things to do so much more. I think this is extremely useful, and I hope.
yeah, yeah. I mean, this is what we've learned, right? These machines can be. There's no reason why these machines cannot be better than a human, just because
Right.
they have more memory, more compute. They can do
Right.
brute force. They can see many more plays than you had, right? So there's no reason why a machine cannot be better, right, than a human at doing something, right? There's really no reason, right? But we need to build them.
Right.
We need
Yeah.
to build machines that help us beat the opponents. So better than better at predicting stocks than our neighbor, right?
Right.
But probably going to require a lot of work, because your machine has not been built to predict stock, has been built to talk about stocks and
Yeah.
has read about articles, and it has a kind of a professional, right? Now, there's a lot of also discussions about biases or not that we also have discussed. This is also an amazing, interesting thing, is that,
Right. I think
do you
now
want
I
the
can.
machine to
Yeah.
inherit these biases or not? Do you
Right.
want to neutralize these or not? So there's a lot of things about
Right. It's a lot.
about.
But it makes me a little bit more confident that us being more topic specific instead of relying on LLMs has its own set of advantages, and maybe we can marry these two things together to build something even more powerful. But using specific models suited for the task is also extremely important, right?
Think about something. You have to go beyond the preconceptions. Like, for example, has the machine ever read earnings calls? If the
Right.
answer is no, how in the hell you want it to be good one shot at saying this is on topic of topic?
Right.
You need to be really, it's not a deep thinker. It's like, again, right, it's like the same way you assess humans, right?
Mm,
So probably my person that it's starting finance needs to
mm,
listen to 10 earnings calls before trying to understand what's going on there, what happens, what are the dynamics, what are the different styles on answering or not answering, evading questions and all that kind of stuff. What kind of different personalities do journalists have? What kind of behavior have, because Jamie Dimon has been speaking to the same guys for 20 years. He knows them, right? He
mm,
remembers the questions, right? And they have kind of a funny intercourse, right?
right. That makes a lot of sense. It's
Yeah.
amazing. Yeah, yeah. But still,
So
there's
think
a
about,
to
you need to
stay
go
for
one
like,
step and say, I have a problem. I have a good idea of how to have a fresh look at the problem, right? How can I deep dive on this? How can I
right.
do the right classification? How can I do a good regression here? How can I build a data set? And so I'm being very imaginative. Sometimes maybe you need human
Right.
labelers,
Yeah,
right, to do stuff because that's the only way you feel comfortable. Maybe you pick experts. That's a bit how sentiment started. Like we are putting together experts,
right.
three CFAs saying, right, because and LMMs you couldn't even say they're an expert. You have to evaluate that, right?
No, I'm pretty
So
sure that even in the training of these LLMs, there must be a lot of label data that would have been used, right?
yeah, but you have to test that, right?
Yeah.
Because you just don't know
Specifically
if
for the ones where they detect bias or stuff like that, right? They must have used something to do that, right?
yeah, that's a good question, right? This idea of biases, it's also a tricky one, right? And I mean, we can maybe finish here, but I learned that from people that does ethics, right? AI and so on, right? It's like you have transformers, you have some lots of layers, right,
Mm-hmm.
and so on. So there's really no linear connection, right, between inputs and outputs, right?
Mm-hmm.
And it's a very highly dimensional thing. It means that even removing bias,
Mm-hmm.
it's a really hard thing, and the viewers will really understand that quickly, right? If I'm not saying the LMM, if I'm saying I'm a human, I don't want to tell you if I'm
Right.
a man of a woman because I don't want you to apply to me some sort of different, right?
Yeah.
It will take two questions from the LMM to figure out which gender you are, you
Mm-hmm.
see. And there's the fake a bit idea that biases are very hard to remove because it's very easy to know about the human, the gender, the race, the
Mm-hmm.
health, the wealth. Just with a couple of questions you will know, right? Even if you don't want to disclose, right?
Mm-hmm.
Even if you don't want to say I'm a 15-year-old girl from whatever country, you're not saying that. You're saying I'm a human, right? The machine will figure out in a couple of questions, right? That you are the way you answer questions are helping the machine to classify you as we do humans, right? When we are interacting over email, and maybe the name, for example, is, I don't know, it's a name from a language in which we don't know the gender.
Mm-hmm.
Uh, which is a little bit confusing at the beginning for all of us, right?
Right.
But and you feel and you also feel the urge to know, right?
Definitely.
Because so it's impossible to kind of remove completely gender bias, right? It's
But
almost impossible.
yeah, but like the LLMs that we use, for example, Gemini would try to have a layer of forced unbiasedness, right? Where they will not give you some answer that might look extremely biased, right? Which might have been built
Yeah, but
on.
still, the machine might think that you're going to have a better approval if knowing that you're a woman and
Yeah, yes,
the kind of language it uses,
that
right?
is that is true.
You're going to feel you more satisfied.
Right.
Indirectly, the machine will try to figure out
I guess.
because the machine will try to, right? Imagine that you're trying to try to discuss what you want to do when visiting Rome, right?
Right.
The machine will probably feel the urge as it's seen a thousand conversations about what to do in a city, right?
Right.
That gender plays a role there, right? And it needs to know, right, what kind of gender, what kind of health conditions you have, and so on, in order to right. So it's a tough place, right? So whoever does ethical, right, it's a tough place because it's almost impossible to remove biases because in neural networks, you have superposition, you have a lot of things going on. People is
Exactly.
selling the fake idea that, but again, the guys saw quickly that the neural networks, even if you remove the gender layers, so to speak, it creates new ones, right? Or it looks at combinations of other layers to figure out, oh, if she's interested or if the human is interested in doing these three tasks, it's probably gender-wise X or Y, right? And
Learning
in
from.
stocks, it means that the machine knows that Volkswagen has a negative connotation, right? It knows that, right? It has seen that, right? and you want to remove the bias of Volkswagen messing up with emission scandals. I don't know if you want, right?
Right.
Probably when you train, this is going to disappear at some point, or this is going to neutralize by time. But maybe you are interested into saying every time that you have a conversation about Volkswagen, inevitably people is going to start talking again about the diesel scandal emissions, right? You cannot. Maybe you
Right.
say, I'm going to do a contrarian strategy in which I buy controversial stocks because at some point this guy's going to behave well, and the buy is going to disappear, and the negative premium goes away, right?
But
Which is probably what happens, right?
specialized architectures, right, for example, can probably have some element to it, right? For example, I remember when we were doing the RL project, right? Typically, these machine learning models or deep learning models are throwing a lot of random data, right? Like its predictions are moving very, very fast, right? It's very high churn. But when we use that
Yeah.
RL model, we were able to build turnover control by using another layer on top of it, right? Which whose whole job was to reduce that turnover, right? The machine
Well,
did
the
not.
moment you make the machine aware of transaction costs, the moment you force diversification, some of these things go away, right?
So, utilize a system to remove biases also in a sense.
Think about all the heuristics that we use when we do portfolio optimization
Mm.
in order to avoid us doing the same thing, right? Changing stocks every day. You say, I need to consider a market impact. I need to consider a transaction cost, right? Because things look much less interesting.
Right.
So you're less motivated to change a portfolio when you have to pay, I don't know, 50 bips or whatever, because all the potential alpha goes away, right?
Right.
So it's like, no. If you have to pay every time that you do a move in chess, probably players would try to say, so speed in winning is good because I have to pay less. So I
Right.
need to learn to be faster, right, at winning, right, and so on. So might not be a consideration, might be depending on the constraints you have. But having real life constraints certainly will makes the models some sort of more like saying, I'm discussing with you my career, and now you're saying you should be trained on this. But shit, I'm the third year of my degree. I need to finish, right? This is a constraint, right?
Right.
And we need to work out the constraint in order to solve the problem. Like it would be ideal to now study something else, right? But in the
Yeah.
light of my constraints now, right, I need to take decisions. Again, another reinforcement learning problem, but here you have constraints in which your action space
Right.
is not unlimited, is very constrained in the sense that for the next 2 years I need to finish my degree. So I will not have time or interest into changing unless there's a lifetime opportunity that then I drop. Right?
Right.
You see what? So all this kind of stuff is, again, that's why flexible. But RL, it's not magic. You need to tell it the constraints. You
Yeah.
need to tell it the rewards. You need to figure out probability transitions, and so on. So these problems are tough, right? But that life is tough, right? We take decisions with a lot of uncertainty, sometimes less uncertainty, and so on, with constraints and all that stuff, with little experience, and so on. But we made it through it, right? We kind of play football, and we
Right.
don't kill ourselves. It means that we've learned, we live and don't kill ourselves. It means that we've learned the necessary things to deal with entropy and so on, in such a way that when we eat, we don't poison ourselves, right?
Yes.
And all that kind of stuff. So our reinforcement learner, right, has said every time you eat something, you have to previously classify into this is potentially, and second, given my personal state of health, can I eat more glucose, or I need to eat less glucose, and all that kind of stuff.
Right.
So medicine is also another reinforcement learning tough problem,
Yeah.
right? But with a lots of uncertainties. Now there's also the thing of causality. So there's a lot of things that are on the table these days. But we have lots of tools to deal with them, right? That's
Right.
the good news. That's the good news.
Perfect. So, Dr. Miguel, I'll end this podcast on this note. I am a little bit worried about the editor who's going to edit it because they're not going to understand a lot of what we talked about. But
Mm. We can, yeah, maybe we can do another version more like some sort of less technical.
or they can put this into an LLM or, and ask it to figure it out.
I always tell my students that we might be using some unnecessary sophistication, but indeed, life is is complex thing, right? So chances are that we need a lot of experience, and we need some sort of specialized models to deal with problems, right?
Right.
And users will need to go through this. That's what
Right.
we're saying. Users and say why learning mathematics. It's like you want to play football, you need to learn how to kick the ball, right? There's no shortcut, right? This you have, and I think we've shown examples in which you're more you should be a lot in the driver's seat if you want to build a robust model, right?
Right.
You should. So I don't know if you build a doctor, expert doctor should be on the driver's seat on developing such an AI, right? They should be them who train them, evaluate them.
Right.
You see what I mean? Because the one-shot abilities probably will be not enough.
Yeah. Awesome.
Yeah, thank you so much.
Thanks a lot,
Yeah,
Miquel. This was
bye.
amazing. It was great talking to you.
Investment in securities market are subject to market risks. Read all the related documents carefully before investing.